Kalau ada Alda.
Alda mau pakai ya boleh.
Alda, come here. Sini mau Pak.
Kak, tapi dulu kan deh. Kak dulu sini dulu. Gini di samping Kak, sorry. Sorry Kak di sini. Cece, ambil laptop dulu. Halo Cahya.
Multi talent memang ini. Apa itu? Kamu pakai gelas?
Plastik. Gak apa-apa dia juga tanya. Bertanya juga kan. Ya, terima kasih.
Cabut ini, tapi ada kegiatan di sini sebentar.
Itu aku bilang. Mana tuh? Masih juga.
Dispenser Pak cabut. Enggak ada dispenser Pak. Dispenser.
Dispensernya yang provinsi.
Dan dispenser. Karena di ruang senam ada setahu sebentar kegiatan.
Itu aku bilang sama kita ada. Itu tadi aku bilang nggak ada kegiatan karena mau isi air. Nggak ada Kak. Ada Kak bisa dispenser dia lu. Ada Kak dispenser bisa dikasih minum ya Kak. Ada di dispenser ruang senam. Nggak mau ada acaranya di ruang senam sebentar. Pakai.
Kenapa nak? Kayak ada perasaan
Saya juga.
Tenda.
Saya juga.
Ayo, kayak begini.
Ayo nak kompak ini.
Dispenser mana nih? Mau isi air.
Pak ya. Dispenser dulu kan?
Butuh refill air.
Jam berapa?
Luntur ke orang baju dari Ampang.
Iya,
Dua perikanan.
S2 Kak.
Dosen anunya tuh dosen hembes ke pertemuan.
Butuh
Zoom kah?
Alia.
Alia butuh Zoom. Yang ini asli.
YouTube, like YouTube Kak. Masuki. Masuk Pak.
Wih, tahu ada yang nih.
Ada nih materinya Kak. Nggak ada Pik.
Dia mau curhat langsung Bang.
Nggak apa-apa Ji, bisa Ji.
Kayak kuasa di Pemda begitu tiba-tiba mau dancing apa?
Gimana kita pakai biasanya kita kok orang kelurahan ini. Nggak bisa kayak nyambung. Bisa nyambung. Bisa. Iya.
Ada kelas apa lagi?
Nah, sudah tadi Pak.
Sudah connect.
6. After master ceremony will open.
I see.
Standing to make presentation or
Yeah, I'm comfortable walking around. I,
ini judul ini.
Hiroshima University Summer Course 2026 participants, all students, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Thank you very much for your attendance today. Welcome to the guest lecture by Professor Masayuki Kondo entitled Estimating Greenhouse Gas Emissions and Absorption in Mangrove Forest. I am Andi Alia Yusria as a moderator and will guide you today. So, ladies and gentlemen, before we begin, I would like to invite the Vice Dean for Partnership, Research, Innovation, and Alumni of Faculty of Marine Science and Fisheries Hasanuddin University to deliver his speech and officially open our agenda today. To Professor Mukti Zainuddin, time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirabbil alamin. Allahumma shalli ala sayyidina Muhammad wa ala sayyidina Muhammad. Good morning, everyone. Distinguished Professor Masayuki Kondo from Hiroshima University, respected college, all students, both from Hiroshima University and also from Faculty of Marine Science and Fisheries. Thank you very much, Professor Kondo, for visiting Faculty of Marine Science and Fisheries, Hasanuddin University. On behalf of Faculty of Marine Science and Fisheries, Hasanuddin University, I would like to warmly welcome Professor Kondo and all of you to today's guest lectures. Honestly, we very pleased to host these important events and to have Professor Kondo with us to share the knowledge on estimating greenhouse gas emission and absorption mangrove forest. I feel this topic is very important, especially because of mangrove ecosystem play a significant role in the coastal environment management and also climate change mitigation system. I hope today's lectures provide valuable knowledge for all of us and also encourage this a good discussion and also open opportunity to develop our collaboration between Hasanuddin University and also Hiroshima University. Finally, I would like to express greatly appreciate to Professor Kondo for accepting our invitation and also sharing his expertise with our academic community. I hope these lectures we can enjoy at all, and also I hope all participants actively participate in the discussion. Okay, let's together to open officially this event by saying Bismillahirrahmanirrahim. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, thank you very much, Professor, for your speech for this opening today. Ladies and gentlemen, maybe before we begin our main agenda, maybe we can take a photo session first. So please, all participants, come to the stage. We can take a picture first. Yeah, Jadi adik-adik mungkin bisa maju ke depan, ada juga yang di belakang mungkin bisa. Oh, okay, yeah. So just stand up, just stand up, or maybe you can sit. Yeah, maybe you guys can stand up because we will take a picture from this side, and maybe Prof Kondo and Prof Mukti will stand up in front of you guys. Okay. Silakan, Bro. Dari depan aja, dari depan aja. Dari sini kan? Dari depan sini. Iya.
Okay, everyone.
Maybe other pose?
Okay.
Like the first time, like this, or maybe this.
Long side.
Oh, okay.
Long side. Okay, one, two, three, pose. Okay, another one is L.
Oh, okay.
Yeah.
For C in Indonesia, it's laut.
Okay, one, two, three. One, two, three. Okay, guys.
Are you prepared?
Yeah, standing. Yeah.
Okay, so ladies and gentlemen, without any further ado, please welcome Professor Masayuki Kondo to deliver his lecture today. Please, yeah, clap your hands. Time is yours.
All right. Thank you very much for having me. This is I'm very looking forward to this opportunity because this is my first time to give a lecture to the Indonesian student at the Indonesian University, Hasanuddin University. I was asked to give a lecture about greenhouse gas emissions and absorption in the mangrove forest. But before I do that, I need to make sure that you understand about climate change or the greenhouse gases. So the first part of this lecture is for me to understand whether you understand climate change and greenhouse gas dynamics. Is that okay? Okay, good, all right. So this is a brief information about myself. I'm from Hiroshima University, and I had education in the University of Texas at Dallas. I stayed in the U.S. for like 12 years, and got a degree in Hokkaido University. Where's Vice President? Where's he? Oh, okay. We had common. We graduated from the same university. And I have been working at many places in Japan. And 3 years ago, I moved from Nagoya University to Hiroshima University. And here I am. All right. Let me ask you very simple questions. So please take a look at that. I listed very, very simple questions. First thing is global warming really happening? And next one is greenhouse gases truly increasing in the atmosphere? The third one is carbon dioxide, the most important greenhouse gas because we make so much noise about CO2. And what are the roles of land and ocean in global warming? The last one is the global warming a phenomenon limited to present day? So it's really fundamental and very simple questions. So let me start from here. Is global warming really happening? we have Hiroshima University students here, and for the last few days, our students experiencing a different climate. So this is tropical climate, which is different from a Japanese climate, which is temperate climate. Okay, so this is the global temperature. Have you seen kind of global temperature? Yes? Yes? Okay. So this is the global temperature starting from 1860 to 2025. What kind of characteristic do you see from here? I don't expect any fancy answers, just a simple observation. What do you see? What are the characteristics of this global average temperature? Anyone? What are the fundamental characteristic? Temperature is increasing from where? 1960. Okay. What about before 1960? Okay, steadily increasing. That's true. What are the okay, more fundamental characteristics? What do you see? Yeah. Okay. Don't get okay. Maybe because I mentioned global warming, you keep paying attention to the increasing pattern. Is there any characteristic do you see? Oh yeah, yeah. What are you doing? Yeah. So it's annually it's going up and down. That's the first characteristic you had to notice. And other thing is that, do you see any decadal wavy pattern before 1960? You know, the wavy pattern. Let's say, okay, pointer. So do you see a wavy patterns for like happens in every decade or so, right? So these are the major characteristic of temperature itself. So one of the characteristic is going up and down, right? And second pattern is going up and down, but with decade for every 10, maybe 20 years. And the last pattern is that straight increase, okay? So we talk about, global warming. We pretty much focus on pattern 3 here. But it's really important to understand, because we focus on this one too much. But we need to understand climate itself. And important thing is that we need to understand natural climate in addition to anthropogenic global warming effect. Okay, so we have to understand natural climate pattern are pretty much determined by the change in the ocean surface temperature. So ocean surface and atmosphere makes natural climate pattern. So everybody know about ENSO. I hope so, right? Because you guys live in a tropical region, so we know, you guys know about El Nino, La Nina stuff, right? So in the news, weather news, they may say this year is El Nino, maybe last year was La Nina. So you don't have to remember details about El Nino, La Nina stuff, but El Nino is the phenomena with the Pacific Ocean gets warmer than normal year. So center of Pacific gets warmer than normal year. And warm temperature and water vapor interact with atmosphere. And during the El Nino year, the pattern is pretty much same. Average global temperature gets warmer. right? Average temperature gets warmer during El Nino year. And La Nina is the opposite to the El Nino. That means Pacific sea surface temperature get cooler. No. I'm sorry, that's the opposite. But in any case, during the La Nina, the average global temperature get cooler. Okay, so that's why, and so this phenomenon is called ENSO. Okay, so ENSO is a very, very strong natural climate phenomena. So that's why you see the temperature increasing up and next year going down and up and down because that's the El Nino year, La Nina year. So it's continued like that. So ENSO is responsible for interannual variability. We call the annual variations is interannual variability. And also, there's so many natural climate like that, natural climate mode like that. Okay, so the second pattern is that Pacific decadal oscillation, which is caused by the sea surface temperature changes in the northern Pacific Ocean. During the positive phase, average global temperature gets warmer for next 10 or 20 years. In the negative phase, average global temperature get cooler for next 10 or 20 years, right? That means the global average temperature is a combination of many things, like El Nino, La Nina, interannual variability, and also decadal wavy variability caused by PDO, and also the continuous increase. That's what we focus on today, okay? So that's why you see that very interesting strange pattern here. So that's the case of global, okay? That's global. And let's talk about the very, very local temperature. So you guys live in, how many years you've been living in Makassar? Maybe longer than then, 10 years, 20 years, maybe more. Yeah. So did you have chance to take a look at weather, long-term weather data close to your resident? Do you have a chance to do that? In Japan, we can do that because every weather station data is freely available. All right. So let's take a look at the temperature in Tokyo in July. So the temperature in Tokyo, we have very, very long record starting from before 1880 to the current period. So we see the increase in temperature. So this is the average temperature, okay, in July. Okay, so this is the maximum temperature in July. Do you see any difference? And let's continue. This is the minimum temperature, right, in July. Okay, so you can see that increase in every year pattern. You can see the increase in pattern average, maximum, and the minimum temperature. So this is the one of the city in Hokkaido area, northern part of Japan. It's very cold area. And if we look at average temperature, increasing rate of temperature is not so compared to the case of Tokyo. And this is the maximum temperature, right? And now this is the minimum temperature. Right now you start seeing some characteristic. I hope so. Okay. So this is the case of the summer, July. Okay, so we are from Hiroshima. So let's take a look at the temperature in Hiroshima city. So this is average temperature, and this is the maximum temperature. And this is the minimum temperature. Okay, this is the case of July, summer. All right, now you start seeing the pattern. So what kind of pattern do you see? What do you see? Yes. Yes. So yes, I guess you want to you want to say that increase in minimum temperature is greater than maximum temperature. So let's take a look at the winter then. Okay, so this is the case of Tokyo. Temperature in July. Okay, so this is average temperature. So this is the maximum temperature. About minimum temperature. Okay. Okay, so let's take a look at the same city in Hokkaido. This is average temperature in January. This is the maximum temperature, and this is the minimum temperature, right? And same for the Hiroshima in January, average temperature, maximum temperature, and minimum temperature. All right. So the long-term global warming, we don't see strong signal in maximum temperature, right? The effect of global warming appears in the minimum temperature. Okay, so we have to keep that in mind. So what kind of a social economic impact minimum temperature increase may cause? When we talk about global warming, people may, maybe you think about, hot summer, but that's not always the case. We have to pay attention to minimum temperature, and the winter temperature has been increasing significantly. Okay. Right. So far, so good. Okay. Okay. By the way, is this something new to you? Okay. So you haven't done any kind of this fundamental knowledge sharing in your class? Not yet. Okay. So you may want to repeat the exercise for your city, and you will find the same. Okay. All right. So the greenhouse gas is truly increasing in the atmosphere because now we know that increasing greenhouse gas is responsible for the global warming. So greenhouse gas truly increasing in the atmosphere. That's something we need to understand. So this guy, Charles David Keeling, is the first scientist who have successfully measured atmospheric CO2 so accurately. So he measured atmospheric CO2 in Mauna Loa in Hawaii, and this is that his first. He started the measurement, continuous measurement, starting from late 1950, and it has been continued on. So you see that the characteristic in these distributions, like going up and down. Why atmospheric CO2 in Hawaii going up and down? Why not straight increase? Why going up and down? Yes, go ahead.
In summer,
Mm,
hot water sea absorb some CO2
okay.
because
Okay. Okay, so this is the Department of Marine Science. So who knows the first principle of CO2 absorption in ocean surface? Who knows? Who knows the first principle? Who knows the first principle of atmospheric CO2 absorption to the ocean surface? First principle. No one? Say? Say again? So, okay. Answer to my question. Here come. Hotter the water, seawater. Hotter the water. What's going to happen to CO2 absorption? How about cooler the ocean surface? What's going to happen to CO2 absorption? Hmm. Okay. Right. Then the answer is that ocean CO2 absorption to ocean surface gets facilitated when ocean surface temperature gets cooler. Okay. So warmer the ocean surface temperature, CO2 absorption gets less. So the ocean has lesser role in this distribution. Okay. So what else? What else can you think of? What else can you think of this, gaggy? Yes, go ahead. Where's the microphone?
In summer, plants absorb CO2 for how to say, Kogo say, I don't know. Photosynthesis. Okay.
Yes, that's correct. This is actually reflecting the activity of vegetation in land. So in the summer, atmospheric CO2 goes down because land vegetation absorb atmospheric CO2. And in the winter, we're talking about the northern hemisphere because Mauna Loa, Hawaii is located in northern hemisphere. So in the winter, most vegetation in northern hemisphere is deciduous. Deciduous means it's dropped leaves during fall and winter. Okay, so there's no photosynthesis during the winter period, so atmospheric CO2 increase. So that's why. Oops. Yeah, we see this pattern. So this is basically a land vegetation photosynthesis responsible for this pattern. And we also see the of atmospheric CO2. And as we know, this is caused by CO2 emission from the burning fossil fuel, right? That means caused by human activity. Okay. But do we know anything about before 1958, before Charles Keeling started making the measurement of atmospheric CO2? Do we know anything about atmospheric CO2 before 1950? Anyone? No one? Any ancient record, older measurement, any archive? Yes.
I'm not sure, but I heard about the 南極大陸ってなんて言うんですか？南極大陸 The continent of 南極大陸ってなんてAntarctic continent Antarctic Yeah, so we can measure the amount of CO2, like ancient record, but from the antique continent, the thickness of ice. Yeah. Thickness of ice, or like from the ice from the
More precise word is that air trapped in the ice. Okay, so okay, so this is actual picture of Antarctic ice, and Antarctic ice get accumulated over the year undisturbed, and air get trapped inside ice core in Arctic ice, and scientists has been working on extracting air from this ice core for many years, and because of those scientists, we can extract information in the past. So this is the result. So this is the actual measurement of atmospheric CO2. This is reconstructed atmospheric CO2 from ice core. Okay. So starting from close to middle of 1750 or so to 1990, you see the increase in 60 ppm. Okay. So it took more than 200 years to increase atmospheric CO2 by 60 ppm. But now, again, we see another increase, sudden increase in atmospheric CO2, same 60 ppm in only 30 years, right? So this is really important. So that's why people are talking about we need to do something about this, right? Good. All right, so let's go back to average temperature. So this is the atmospheric measurement. It's going up. So we know that pretty much atmospheric greenhouse gas like CO2 are responsible for the increase in temperature for the recent years, right? Okay. Okay, so do we know, is there any evidence of greenhouse gas effect? So we know that, the people are making noise about, we have the global warming now because of greenhouse gas effect. So what is the most important evidence of greenhouse gas effect? We may be having a global warming because of strong solar activity. Why greenhouse gas? Why do we know greenhouse gas causing the global warming? Why greenhouse gas is responsible for the current global warming? There is strong evidence. Okay, let's think together. Okay, so I guess I hope everyone during the high school or the college level introductory class, you know about the mechanism of greenhouse gas effect, I hope. Right? So when sunlight hits Earth's surface, some of that radiation from sun gets returned to the atmosphere, but the rest of that going through the clouds and reach to the Earth's surface. Okay? But Earth is also emitting radiation. It's called long wave radiation. And atmospheric CO2 it has characteristic of capturing the Earth's heat in form of radiation and return to the Earth's surface. So that's why it's called surface warming. Okay. Okay. Here's the hint. Every interactions happens between the troposphere and the stratosphere. So our atmosphere has several structures. The lowest layer of atmosphere is called the troposphere, and next one is stratosphere, and the one above it's mesosphere, thermosphere, exosphere. Okay. By looking at this diagram, can someone tell me what is the strongest evidence of greenhouse gas is actually the cause of global warming? To convince ordinary people greenhouse gas is responsible for the global warming, what do you need to indicate? What do you need to show to them? Any idea? Any opinion? Any idea? Anything? So let's assume there are less atmospheric CO2. What's going to happen? What's going to happen to this diagram? Nothing? No idea? Okay.
I think the evidence is damaged ozone layer.
Okay, ozone layer is another topic, which has nothing to do with this topic, but nice try. Right, anyone else? Okay. So this is, okay, let's see, this is the surface warming in troposphere. What's going to happen to stratosphere? Okay, greenhouse gas called warming in troposphere. What's going to happen to stratosphere? Yes.
The temperature in stratosphere cooler.
Yes, that's right. That's right. Okay. So if greenhouse gas in atmosphere is responsible for warming in the Earth's surface, there should be counterpart of cooling in stratosphere, because Earth's heat supposed to be go up if there are less greenhouse gas in atmosphere, and supposed to have the same warming pattern during between the troposphere and the stratosphere. So we have more greenhouse gas in the atmosphere, which is block the Earth's heat going outside, okay, and bring it back to the surface. So global warming of today is caused by greenhouse gas because we observe the cooling in the stratosphere. Actually, we have the measurement. We deployed a radio zone observation, which is unmanned balloon observation, and we actually measure the temperature in the stratosphere. And as you see, troposphere is warming, and this is a counterpart cooling in stratosphere. So this is the strongest evidence of greenhouse gas is responsible for the warming in troposphere. So in other words, current global warming is stratospheric warming. So this is the correct term. Okay? Good? Right? Okay. Are you happy now? Okay, good. Right, so, but this is very, very fundamental in climate science. And Okay. But anyway, okay. Okay. Another topic. So, is carbon dioxide is the most greenhouse gas. So there are several greenhouse gas in the world, and of course we have CO2. There are another greenhouse gas like methane, CH4. Another one is N2O, NOx, halocarbon, CO, carbon monoxide, and non-methane VOC. So these are the major greenhouse gases. Why CO2 is the most important? Why we care so much about CO2? Why government try to limit the emission of CO2?
Sensei, maybe I will translate your question to Indonesian language. So maybe
Okay,
they
okay,
can-
okay, okay.
yeah.
Please do that.
Maybe can you repeat your question, Sensei? Okay.
Why?
Sorry.
Okay, so it's not why carbon dioxide is the most important greenhouse gas.
Oh, okay. So adik-adik sekalian, kira-kira apa yang menjadi alasan kenapa CO2 itu menjadi hal yang paling penting untuk greenhouse gas? Ada yang mungkin yang bisa menjawab? Ada yang bisa menjawab? Nggak usah malu-malu deh, dalam bahasa Indonesia pun nggak apa-apa. Iya, nggak apa-apa. Masa dikalah sama mahasiswa Jepang, dari tadi mahasiswa Jepang yang angkat tangan. Ayo deh, nggak apa-apa deh. Ini saja, apa ya? Kalau salah pun tidak apa-apa. Kita akan di sini sharing, diskusi gitu. Apa kira-kira kenapa karbon dioksida itu menjadi hal yang paling penting pada greenhouse gas?
Okay, so do they understand you?
Iya.
Okay, good, good. So why CO2 is the most important greenhouse gas?
Yeah. Maybe anybody, could you raise your hand? Okay.
Yes, go ahead.
Okay, please.
I think because it has the biggest emission, because the human activities will just make plenty of the CO2. So it's the biggest emission.
Are you talking about quantity?
Yeah, quantities.
Quality.
Yeah.
No, quantity.
Quantity.
Okay. Okay. That's actually correct. So concentration in atmosphere is highest, except H2O. I mean, H2O is also the water is also the greenhouse gas, and except water, CO2 has highest concentration in the atmosphere. What else? Why CO2 is important? Okay, please don't please don't talk to your friend Chappie. Anyone else? Okay, who's my chemistry guy? No one? No one specialized in chemistry? Maybe not?
Ada yang orang kimia. Basically, we don't have any mostly like in chemistry.
Not even the marine chemistry?
Marine chemistry. Ada yang oskim. Oskim. Ada yang tahu yang mungkin pernah belajar oceanografi kimia?
No one? Okay.
Ada oh itu. Oke, silakan deh. Oke.
Okay, give it a try.
Ya, silakan dicoba. Tunggu mic, iya, tunggu mic-nya deh. Oke.
Jadi jawaban saya adalah mengapa CO2 itu sangat penting bagi kehidupan di bumi, karena dia ini adalah gas yang menopang fotosintesis tumbuhan di bumi. Seluruh dan menjaga suhu planet.
Okay. Okay, so he said that why carbon dioxide is important because this gas support the photosynthesis and also maintain the planet's temperature. They have a role in maintaining the planet's temperature.
Thank you, thank you, thank you, thank you very much for your nice try.
Okay.
Okay, next characteristic why CO2 is important is that CO2 doesn't go through any chemical reaction, almost no chemical reaction in atmosphere. That means if CO2 are emitted to the atmosphere, it stays. No chemical reactions occur in atmosphere. Okay. Having said that, what will be the last characteristic?
Okay.
So CO2 is very stable in atmosphere. What are the other characteristics? It's maybe a difficult one. So okay. So other greenhouse gas go through chemical reactions and eventually turn into CO2. Okay, so we have a bunch of CO2 and we have other greenhouse gas, but they go through a chemical reaction and become CO2 in any way. Good? Okay. So that's why we care CO2. Good? Good. All right. So this is the, you don't have to understand this very well, but it's basically said, by the way, this is from the IPCC Assessment Report 5. So CO2 has strong warming effect. So this bar represents the strength of warming effect, and followed by other greenhouse gas like methane and N2O, and some aerosol and dust in the atmosphere. It can cause cooling effect and also a warming effect, right? So CO2 is most important greenhouse gas. Okay, let me ask you this, but what about water? So I mentioned that water has most abundant concentration in the atmosphere. Why we care so much about CO2? Why not water? Why we don't care about water?
Okay, mungkin maybe I will translate it again. Okay, jadi adik-adik kan air itu juga banyak di atmosfer gitu, tidak hanya CO2, tapi kenapa yang diperhatikan itu malah hanya CO2? Kenapa airnya tidak? Kenapa kira-kira? Oke.
Jawabannya itu Bu, karena itu CO2 jangka panjang Bu, sebagai iklim jangka panjang.
Kalau air? Kenapa?
Kalau air itu dia itu mengumpan balik Bu, dia sebagai umpan baliknya.
Okay, so he said that maybe for carbon dioxide, why it is more important rather than water, because carbon dioxide could be storage in a long term rather than water.
That is very good answer. Okay, all right, but let me add extra essence to it. So this is the picture I took on the way to Indonesia. Right? So do you see any feature from this photograph? I took this with intention. Do you see any feature? So, okay. The below is troposphere. and above is stratosphere, do you see any feature between these two atmospheric layers? What do you see? What's the difference?
Color is different.
Very nice observation. All right. What else? Huh?
I think it's the texture is more blue, on is more texture. So I think this is it. Thank you.
Very good. Thank you very much. Do you see? Okay, you see a bunch of clouds in the troposphere, but you don't see any cloud in the stratosphere. Isn't it? No cloud in stratosphere. No bunch of cloud in troposphere. Basically, the cloud can form only in the troposphere. Okay. And there's a condition for the cloud formation. One is, of course, water vapor, right? And also the aerosol. Without aerosol, there will be no cloud. Okay? So the aerosol is very important. So because of aerosol, there will be the vegetation, there will be the evaporation from the land surface and provide water vapor to the atmosphere. And water vapor interact with aerosol and form cloud. And it's bring back to the Earth's surface through the rainfall. Okay. So like you said, water vapor cannot get accumulated in the troposphere because it comes and goes. It comes and goes. Not in not like CO2. CO2 stays. Water vapor cannot stay. But this is the story only for the troposphere. How about in the stratosphere? Can water vapor go through the layer between troposphere and the stratosphere? There is no aerosol, almost no aerosol in the stratosphere, by the way. That means if water vapor can go through the layer between troposphere and the stratosphere, it can stay for very long years, very long time. And it can act as greenhouse gas. You see? Right, so there's a mechanism feeding the water vapor through the stratosphere, which is overshooting convection, which happen in tropical region like Indonesia. So in tropical region, there will be a super convection. It's like atmospheric circulation is super convection happens in tropical regions. So it's bring water vapor to top of the atmosphere. And most of the water vapor cannot get through the layer between troposphere and stratosphere because atmosphere is so cold at the top, like minus 40 or 50 degrees Celsius. So most of the water vapor get condensed and comes back to the atmosphere, but only few goes through and reach the stratosphere, okay? And because of global warming, this cold temperature at the top of troposphere may be warming up. That means water vapor may be easier to get through to the stratosphere, and this can cause more global warming maybe in the future. And Southeast Asia, including Indonesia, maybe this region, a particular characteristic in Indonesia can help facilitate increase in water vapor in the stratosphere through volcano. Strong volcano bring water vapor to the stratosphere. And also strong fire can also bring water vapor in the stratosphere. And so far, our estimate, IPCC estimates like 10 to 20% of current global warming is caused by water vapor in the stratosphere. Okay, we only care about greenhouse gas in the troposphere, but it's very important to understand water vapor in the stratosphere. So water is very important. Okay, that's something you cannot ignore when you talk about global warming. All right, you know what? I'm going to give you guys a little break, but after this topic. Okay, so let's come back to CO2. So the most important source of CO2 emission is the fossil fuel. So we burn fossil fuel and gives CO2 into the atmosphere. So which country is responsible for releasing CO2 to the atmosphere? That's not very fair question, but
May I translate it, Professor?
oh yes,
Okay.
yes.
Jadi kira-kira deh negara mana yang menyumbang CO2 paling banyak ke atmosfer? Kira-kira negara apa yang menyumbang CO2 terbesar ke atmosfer? Oh? Please, maybe you can raise your hand. Okay.
Yeah. Okay.
China.
Okay. What else? China. What else? India. Okay. What else? Russia. Okay. What else? United States. Yes. Okay. So let's look at the actual data here. Okay. So this is the global average. This is okay. Okay. Hold on a second. So this is the case of China. So CO2 emission of China is dominant now. Dominant. And India, which is purple line here, is also shows the increase. Okay. And we know that United States is a major emitter of CO2, but actually it has been decreasing. Emission from United States is actually decreasing. And the emission from European countries is also decreasing. And emission from Japan, it looks stable, but it's actually decreasing. Okay. And, the key country is China and also India. And I don't, I'm very curious about this figure. And that's something I don't, okay, it's about 2 years ago when I look at this figure and I noticed something very strange. Something very strange in this figure. Can you guess what that is? Something very strange in this figure.
Okay.
Something very strange, I thought something very unrealistic.
Ya. So, jadi adik-adik sekalian, 2 tahun lalu Prof coba lihat-lihat ini gambarnya. Terus katanya ada satu hal yang sangat aneh gitu, sangat tidak realistis. Apa itu kira-kira? In your opinion, what is the strange point that Professor Kondo maybe mentioned 2 years ago? Apa? Ada yang tahu kira-kira apa hal yang sangat, ya oke. May you stand up, please? Okay. Okay, and then maybe just answer it with microphone so everybody can hear it.
Terima kasih. Terkait keanehan yang saya dapatkan dari grafik di atas, itu grafik yang berwarna merah. Di situ terjadi peningkatan yang begitu drastis dibandingkan dengan grafik yang lainnya. Ya, mungkin itu saja.
Okay, so he said that he pointed that maybe the red line, which is China, have a very they increase very high rather than the other.
I see. I see. Thank you. That's very good point. The hint is United States. I don't. 2 years ago, I didn't like this figure, especially for the United States, because I couldn't understand. Okay. Who is the current president of the United States? Donald Trump. What is his climate? What his policy on climate change? What is his policy on climate change? Do nothing. Do nothing, right? And before that, he was president once before. And during his presidency, what was his policy on climate change? Do nothing, right? So why emission from United States keep decreasing despite the government policy on climate change is do nothing, or to promote more fossil fuel burning? So that's I know the answer now. I know the answer now, but that's really strange. So 2010, despite who is the president, what kind of policy they have, it doesn't matter. The emissions has been decreasing. Okay, you may want to think about that. Okay, I'm not going to give you an answer though. All right, and you can also see the dip, right? Dips. Okay. What is this? What is the dip? The COVID, right? So we suffered from 1 or 2 years during the COVID-19, but reduction in fossil fuel burning CO2 emission is just a little bit. Okay. How about this one? What kind of event corresponding to this one? Reagan shock. Okay. Okay. Reagan shock or global, in the proper word, global finance crisis. Okay. So that's good. Thank you. And how about this one? 1990. Not correct. You see that, only affect the rest of the world. This is the black line, the rest of the world, and no other major country are not affected by this event. Yes, the Soviet Union. Okay, right. So you can see the structure corresponding to particular event. Okay, and let's talk a little bit about the case of Japan. So Japan has a very organized data set and also the report for CO2 emissions. And actually, CO2 emission in Japan has been decreasing starting from 2012 or so, after Japan ratified Paris Agreement. And you can also see the structure here corresponding to COVID-19 global financial crisis, and this one is also the corresponded to Asian financial crisis. Okay, and the decrease is happens in the energy sector, and also the industrial sector, and also the transportation sector. These are the main sector, but we see a significant decrease, and this event also gives some dip in this structure. Now, what I'm going to show you is not, please don't take it personally. Okay, so this is the fossil fuel emission from Southeast Asian country. The emission from the use of oil, gas, and coal, and also the marine bunker and the aviation bunker here. So Indonesia is among Southeast Asia, Indonesia is the dominant country of CO2 emission from fossil fuel burning. Okay? Okay, like I said, please don't take it personally. Okay. Right, I guess we can take a break here. 5? Yeah.
Okay, so ladies and gentlemen, maybe we could take a break for 5 minutes. Okay, so after that we can continue the lecture. But Professor, let me just remind you that your how to say that your time is only 30 minutes more. Yeah, so before because after that we would like to like question and answer session. Okay. So maybe we can finish it in maybe 11 like 11:15 50, yeah. After that we have like 10 minutes to question and answer session. Okay, Prof. Okay, so we will start again in 11:25. So maybe if you guys wanna go to the toilet or maybe just take your time, and please mungkin adik-adik bisa bantu arahkan ya, siapa tahu mereka mau ke toilet juga. Iya, oke. Thank you. Dek, toiletnya pakai yang di sini saja, nah. Iya, yang di sini, nah. Oke. Could you please just write down your name because it's like only like guest book for of course. Yeah. All international lecturers who come to our university, especially Faculty of Marine Science and Fisheries. L only. L means laki-laki in Indonesia. For men, it's laki-laki. Oh, lucky. Yeah, L. Yeah. Sebentar sih Kak. Maybe apa nih? Iya, oke. Ya, oke. Oke. Nanti bisa tuh Kak. Iya, oke. Thank you nah. Bye. Aduh. Sebentar gini, cerita kita sendiri Kak. Sebentar gini. Nah. Ini makanya sudah bingung. Just sign, and then maybe in this column maybe you can write down like Hiroshima University. Okay, thank you. So this is for your attendance list also. Oh, okay. I would like ask you to sign here for your attendance list. Okay, thank you, Sensei. Thank you. Kamu jangan tolong di-share ini ke dalam layar. Tapi nggak tahu bagaimana caranya. Pak, Liza minta tolong sharekan ini ke layar. Iya, aku tunjukkan nanti. QR. Iya, no?
Okay.
Maybe. Okay. So maybe we will continue the lecture, but please still with us until the end, because at the end we will share the attendance list. Okay, so you can get the certificate. Okay. So after Professor Masayuki Kondo's lecture, we will share the attendance list into the screen in front of you guys. So after that, you can fill it out, and then we can share the certificate later. Okay, thank you. So please, Professor.
Right. Okay, so let's continue. I have a bit more slide, but okay, maybe time will running out. So another question is, what are the role of land and ocean in the global warming? Okay, so atmospheric CO2 stays in the atmosphere with almost no chemical reactions, but we have to remove atmospheric CO2 somehow. There are three major processes. One is photosynthesis. Okay, photosynthesis. And ocean also absorbs CO2. And the last one is that this is a very unique process. It's called chemical weathering. It's a reaction of silica rock and water and CO2 interaction. Okay, but the important part is the photosynthesis and ocean. So this is the reason why we need to have the forest. We need to preserve forest, because CO2 stays in the atmosphere. One of the best method to remove atmospheric CO2 is through the photosynthesis of the forest, right? Okay, so this is that very famous diagram showing that the amount of human-induced emissions. Let's add fossil fuel emissions and land use change emissions, which is two major processes of CO2 emission from human activity. And let's say this is 100%. We add this number. So out of 100% of human activity, land accounts for 20% of CO2 absorption, and ocean about 29%, and the rest stays in atmosphere. That means because of land and ocean, whatever the fossil fuel we burn, we emit to the atmosphere. Land and ocean always mitigate by 50%, and the rest stays in the atmosphere. Okay. Okay, this is more or less the same for every year, more or less. Okay. That means, but we know that from the figure before, the fossil fuel emission has been increasing. Okay, but this rate may stay constant, may stay the same. So what's going to happen to CO2 uptake in land and ocean? Okay, fossil fuel emission has been increasing. This is increasing. What's going to happen to CO2 absorption in land and ocean? Actually, this percent almost stay the same. That means if we emit more CO2 into the atmosphere, land and ocean absorb more carbon. Okay. So this is the really important paper published in Nature. So this is the fossil fuel emission, which is increasing. Okay. And this orange is that land use change emission. Okay. So, but anyway, anthropogenic emissions has been increasing because of the fossil fuel burning. And this is the corresponding CO2 uptake, absorption by land and ocean. So if we emit more CO2, land and ocean uptake absorb more CO2. So this is the power of nature we have. It's not like we can emit more, but land and ocean always mitigate the atmospheric CO2 increase. Okay, so the last one is that is the global warming phenomena limited to present study? I mean, the present day. But this, since we're running out of time, I'm going to skip this one. This is very interesting, though. Okay, let me tell you in word. So we having a global warming today, but global warming, Earth actually experiencing global warming more than once. Okay, more than several times. Okay, so but I'm going to skip this one. All right, and let me ask you one thing. So we know that this is the model simulations of the global northern hemisphere temperature, and we know that we have been emission has been I'm sorry, temperature has been increasing now, but in the past, temperature was also really high. Okay, like decade, like a year of 1,000, or before 1,000, after 1,000. Does that mean the current global warming is not so serious? The present day global warming is a serious problem we should resolve, because we have this kind of high temperature in the past, and our ancestor may have survived. So present global warming is a serious issue. What do you think? We have global warming, yeah, that's for sure. But is that serious? Since we have the really high temperature in the past. So that's the question.
Ya, bagaimana adik-adik? Oke.
Okay. I think that it's still very serious problem, because if we see in the past there is a warmer temperature also, but it means we could decrease the temperature, but now we face the same situation, and now we have to decrease it again.
Okay, let me ask you this way. Maybe in Japan we have a temperature of like 38, in some city like 40 degrees Celsius. Okay. Do you think you can feel 40 degrees Celsius temperature? Do you feel? But today, Makassar maybe 34 degree Celsius or so, right? Like 34. Do you feel 34 degrees Celsius temperature? Do you? Can you feel 40 degree? Can you feel 34? Can you feel it?
Apakah bagaimana Dek bisa dirasa itu temperatur 34 derajat Celcius, 40 derajat Celcius? Bagaimana? Ada yang bisa angkat tangannya, Dek? Just raise your hand.
It's a simple answer. Can you
Yeah.
feel it or not? Yes.
Feel or not?
Mm. Okay. I guess my point is that there's no way you can feel 40 degrees Celsius. We cannot feel 40 degrees Celsius. Okay. We cannot feel the temperature itself because our system is not made to be sensitive to the temperature itself. We sensitive to temperature change. Okay. We sense temperature not in the air, but also the difference between the air and your skin. You cannot feel the temperature itself. You can only sense the temperature change itself. Like we came by plane. It's going like a 200 kilometer per hour, but we cannot feel 200 kilometer per hour. We can feel change in the speed, right? When the plane decelerate or accelerate, we can we can only feel that. Okay. So if I kick you in a hot bathtub, like a 40 degrees Celsius, if I kick you in the bathtub of hot water, 45 degrees Celsius, what's going to happen to you? For yeah, okay. But if I hold you very gently and put in a warm water, like a 38 degree or so, and increase the temperature 1 degree for every 10 minutes interval, what's going to happen to you? I think you can, it's not gonna, you may not react to it. So the point is that our human body is sensitive to change. If change happens so quickly, our body cannot tolerate. Okay, so the global warming, the current issue of global warming today is happens so quickly. Our body is sensitive to change, and we cannot tolerate. And warming in the past happens very slowly. Okay, slowly that even our ancestor didn't even sense the change. Okay, so that's the difference. All right, so this is supposed to be the end of part 1, but I need to finish my talk like in 20 minutes. 20 minutes. Around 20 minutes. So I don't know if I can get to the mangrove. But let me try anyway. So this is supposed to be the part 2, the main part. Part 1 was the pretty much fundamental study. So the part 2 is all about Southeast Asia. It's all about Southeast Asia. Okay, so do you know the word Paris Agreement? Paris Agreement. So what's Paris Agreement? What's Paris Agreement? Yes.
So Paris Agreement is the international treaty which has been ratified by almost every country. It essentially serves as a commitment and goal to limit the global warming temperature under 2 Celsius, and it's being the way that the countries move on to the solutions for this climate change is through their national determined contributions.
Yes, thank you very much. Very good. So every country ratified the Paris Agreement have to do the mitigation of greenhouse gas emissions. And so nationally determined contribution is a really important word. So every country have a commitment to mitigate greenhouse gas. And another important concept is the greenhouse gas budget, which I have been working on for several years. Okay. Okay, so we talked about CO2 emissions from industry burning fossil fuel, and also that land vegetation uptake CO2, but let's take a look at this figure here. So in addition to fossil fuel, there are so many pathways of emitting or absorbing a greenhouse gas, which can be something like this. There are so many pathways. It can be fossil fuel emissions from burning fossil fuel, and the CO2 and also the methane and N2O can be emitted by these processes, and also from a human activity. Agriculture is also the source of greenhouse gas, and land use change, forestry, and also the peat. Peat is very unique ecosystem in Indonesia, and it can also a strong source of CO2 emissions. And the natural ecosystem and also emission can be emission source of greenhouse gas. Wetland. Water can also emit greenhouse gas like wetland. Wetland can emit methane. Okay. And termite. Termite can also emit methane. And the river and lakes, they are also the source of greenhouse gas. Okay. And last one is estuaries and coastal fluxes, including mangroves. Okay. So do you think which components is most strong greenhouse gas sources in Southeast Asia? What do you expect? And also in Japan, and also in other countries. So we need to understand that. So that's what I've been working on. And ultimately, our team is to understand emission is greater than uptake. That means the rest net amount, which is emission minus uptake, is like this. When we call it net source. And if the uptake is greater than emission, we call net sink, which is very good. And emission is equal to uptake with a neutral. And this is the state we want. And this is the best case scenario. And this is the situation we have so far. And what do you think? Is it difficult to estimate so this is the thing called greenhouse gas budget. Okay, adding all these components to understand the region like Indonesia or any other Southeast Asian country or Japan, or totally emitting CO2 or any other greenhouse gas, or total absorption is greater than emissions or not. So to understand that, we need to calculate greenhouse gas budget, and which is very similar to weighting your measuring your weight. Okay, but measuring the weight is really difficult thing. If you can imagine that, for instance, if you want to understand your weight difference from yesterday to today, how can you measure your weight? How do you measure? How do you understand your weight difference between yesterday to today? How? Can you? Huh? Yeah. So you can just, put yourself on the scale and from yesterday to today, and you can take a difference. Okay. But that's not the informations. That's the one of the information. But I'd like to know which part of your body gained weight. Can you do that? Can you measure it for the sake of science? For instance, I'd like to know maybe your head may be bigger than yesterday. For the sake of science, I'd like to measure that. Can I cut your head off? Maybe? No? No? Okay. All right. So we can understand the total difference, but it's really difficult to understand the component. Okay. So it's like measuring the weight is really complicated. So for that, we have created a network within Asian Institute, which is called the League of Geophysical Research Excellences for Tropical Asia. And I am the chair, and we have a very strong scientist from Asia. He's my friend Chandu, working for the company in Indonesia. It's called April. And he's my friend Remy. He's a professor at the National University of Singapore. And Menzi is also the National University of Singapore. Wally is from Zhenghai in China. And Umakan, he's originally from Nepal. And he's been working for the US many years. And this core member requirements to have at least one paper in the natural science journals. So we are very strong organizations. Okay, so we have been working on greenhouse gas budget of Southeast Asia. And when we talk about Southeast Asia, there are many important components like mangroves, rice field, peat, and plantations and forest fires and land use changes, and volcanic activity. Okay, so we talked about El Nino and La Nina. And when El Nino occurs, Southeast Asia gets dry and gets very hot, as you may know. And in that conditions, especially Indonesia and Malaysia suffer from forest fire, significant and massive forest fire. And this forest fire is really significant and really important when it happens on the peat. So of course you live in Indonesia, you know all about that. So when peat gets burned, it can cause significant haze all over Southeast Asia, and it also emits significant amount of greenhouse gas to the atmosphere. And another thing is that land use changes, which is still very active in Southeast Asia. So the obvious consequence of land use change is that the decrease in photosynthesis because there are no forest anymore. But even without forest, their soil remain in the site, and it's facilitate decomposition and emit more CO2 to the atmosphere, right? And okay, I think we're going to skip. I don't know how much time do we have. Not okay. Okay. So okay, I'm sorry. I'm in rush. Okay. So this is that one of the CO2 budget assessment results we have, and you see that the amount of CO2 for 2010 coming from the oil, coal, and gas burning, cement productions, and these are from the land use changes, peat decomposition, the fires. We collected all the data for Southeast Asia, and here's the result for the coastal flux, including the mangrove. Okay, so negative mean uptake, positive mean emission. And Southeast Asia is emitting significant amount of CO2 to the atmosphere. And very unfortunately, mangrove doesn't play much of a role, doesn't act as mitigations. Okay. And here the picture I took when I visited Hainan University's mangrove. I was really surprised that mangroves are really tiny. You can almost say it's difficult to say this is forest. It looks more like shrub. So now I understand we cannot expect too much of CO2 emission from mangrove. But mangrove have other functions like prevention for the disaster, damage controlling of the disaster. So mangroves are pretty much important, but not for the mitigation of CO2 emission and climate change. I don't think it can be very useful for that purpose. Okay, I think this is a very good time to stop. And before, okay, so I like to say one more thing. Before I stop, let me promote one thing. So we have very, very important international conference in Hiroshima next year, 2027, March 1st to March 5th, which is the ILEAPS, which is ILEAPS is the international network, including land atmosphere interactions. You know that the future Earth is that the global organization handling all those, climate change, environmental studies, and ILEAPS is one of that organization, and it's covered many things like global warming, climate change, and stuff. And we're going to have an international conference in Hiroshima City, which can be for maybe 7-8 hours from here, and we're going to have big conference in International Conference Center in Hiroshima City. So if you like to come visit us, please convince your supervisor and bring your very good research result and have a presentation at our conference. Right. So thank you very much.
Okay. Okay, thank you very much, Professor, for your interesting topic to discuss with. So, ladies and gentlemen, if you have any question, you can raise your hands. Jadi adik-adik sekalian juga bisa silahkan kalau misalnya mau bertanya, boleh bertanya. Nanti kalau misalnya tidak bisa dalam bahasa Inggris, saya coba bantu untuk translatekan ke bahasa Inggrisnya. Bisa menggunakan bahasa Indonesia saja. Yeah, so ladies and gentlemen, if you have any question, please raise your hand. Okay, Audi silahkan. Audi please. Ada mic-nya Audi? Ada mic? Okay.
Yeah, thank you very much for the opportunity, Kak. And my name is Audi Rivel Akbar. I am graduate student at Department of Marine Science on this faculty. And also my thesis title was the land cover prediction and mangrove cover dynamics. So having you here is such an honor for me especially. And also it's a great lecture from Prof. Kanjo about this title because that's related to my research. そして誠にありがとうございます。So my question is, we've been seeing the graphic of the temperature of Earth, that exponentially rising in recent decade or years. We could see that before the 50s, the increasing of the temperatures is not really significant compared to the after 50s. And also, Prof, can you mention about the adaptability of human being is not really possible of this fast-moving temperature. And also, we talk about the Paris Agreement, the national determined contribution. Is there any possible in some point of our lifetime that we could turn the table, turn over the temperature in our lifetime, or this whole agreement and plan of restorative mangrove and such other ecosystem only to hold the temperature pre-industrial era? There is no possible in some point of our lifetime that it could turn over. So
Okay.
what's your opinion?
Okay, thank you
so
very much. First of all, I think it's impossible to have the temperature reductions in our lifetime. But there's one possibility. I mean, we still have possible measure, the countermeasure, which is to emit aerosol in the atmosphere. So I hope you remember that 1991 or two, but Pinatubo eruption in the Philippines. It was significant eruptions, and it's emit a bunch of volcanic ashes in the atmosphere, and it's blocked the sunlight, and global temperature decreased significantly. So there are scientists thinking about actually releasing the aerosol into the atmosphere so it can block the sunlight. Of course, we our daily life may not be so comfortable without sun, but we can actually it can actually help reducing the temperature, which is called the geoengineering. It's possible, but I don't know the side effect of that. So I think, in my opinion, it's very difficult to reduce temperature with each government effort, because each government have a different strategy, different aims, and somehow we have to convince China and India to work on mitigations. So I would say it's very difficult. Yes.
Okay, thank you, Professor. Is it clear for Audi? Okay. Okay, thank you very much. Maybe the other questions, if you guys still have a question, just raise your hand, or maybe you can just give a question in Indonesian language, and then I will try to translate it to the professor. So tidak usah malu-malu adik-adik sekalian. Kalau misalnya ada yang mau ditanyakan, ada yang masih bingung kira-kira bagaimana peran greenhouse gas ini terhadap mangrove forest, bisa silahkan adik-adik bisa mengajukan pertanyaan langsung. Nanti saya coba bantu semaksimal mungkin untuk ditanyakan ke profesornya. Bagaimana? Do you have any questions? Oh, okay. Okay, maybe the guy with mask first. After that, the other one. Okay, silahkan Dek. Ada yang bisa bantu mic-nya? Oke. Minta tolong Dek.
Baik, terima kasih atas kesempatan yang diberikan. Pertanyaan saya itu, bagaimana cara kita mengurangi emisi di era kita yang pengeluaran emisinya itu banyak banget, sehingga kita itu bisa menuju di mana kondisi dunia kita itu net sink. Terima kasih. Net sink, iya. Itu sih. Terima kasih. Regato.
Okay. Okay, so he asked about how to reduce this current like high emission, because how to reduce the high current emission so we can reach the net sink, the goal for the net sink.
Okay, talking about which country, Southeast Asia or any other countries?
Mau Southeast Asia, Asia Tenggara, atau ada negara tertentu mungkin? Okay, maybe you can just explain in global and in Southeast Asia for the
Okay,
possibility.
in the case of Southeast Asia, the one of the major emission is coming from the land use changes, deforestation. So maybe reducing the timber activity, because it's very often the common case that Southeast Asia conversion of the primary forest to the plantation is very common. So maybe you can sustain that kind of activity, and also the fire. So the fire is a serious issue. So government may spend money on controlling the fires. So those two are really important factor, especially for Southeast Asian country. Yeah.
Oke, jadi dari Profnya itu bilang mungkin ada beberapa hal yang bisa dilakukan. Salah satunya itu itu kan biasanya disebabkan karena adanya perubahan lahan, seperti deforestation, seperti penebangan hutan gitu. Jadi mungkin ada beberapa langkah-langkah, misalnya seperti penanaman hutan. Jadi untuk memaintain kegiatan-kegiatan yang seperti itu, sehingga kita dapat mencapai setidaknya mendekatilah untuk net sink. Selain itu, saat ini juga mungkin yang paling serius khususnya di Asia Tenggara itu adalah kebakaran. Jadi sangat banyak sekarang kebakaran yang terjadi, sehingga negara itu diharapkan untuk sekarang itu untuk setidaknya dia fokus pada kebakaran itu sendiri. Bagaimana cara mencegah kebakaran tersebut, bagaimana cara mengatasi kebakaran-kebakaran yang terjadi khususnya di Asia Tenggara. Seperti itu. Is it clear enough? Okay. Okay, maybe the next question, please.
Yes. Thank you very much for the opportunity. My name is Basorehan and I'm from Aquaculture Study Program. And my question is, how we know that whether a mangrove is absorb more carbon dioxide than it is releasing it? That's my question. Arigatou gozaimasu.
Okay. How do we know? Because people makes measurement, and mangrove is vegetation is uptake CO2, but in the ground, the soil also emit CO2, and the wet floor is also emit methane. So, but as far as the measurement goes, almost every measurement shows that mangrove is a pretty much net sink. CO2 uptake by vegetation is overwhelming the emissions. So especially true for the young plantation, I'm sorry, young mangrove, because young tree uptake more than older one. So yes, I don't know. In the case of old mangrove forest, maybe emissions can overwhelm the uptake. But in the case of young middle-aged mangrove, uptake always greater than the emissions.
Is it clear enough for you? Okay. Okay, thank you very much. Is there any question? If Okay, if there is no more question, maybe I will ask for the last one. Okay. Okay, Sensei, maybe I will ask for your last one. It's just, because you and your team already have done a lot of research related to greenhouse gas budget. I just would like to know, in your opinion, or maybe based on your research, could we reach the goal of the United Nations for being a neutral carbon neutral in 2045?
We mean Indonesia.
Okay, Indonesia,
Okay,
maybe just Indonesia, or maybe Japan.
Japan is on the way.
Oh,
But
okay.
Japan is on the way, but next 10 years will be the key for Japan.
Yeah.
Because we have reduced 30% reference to 2012, and we need to bring it down to 44% in 10 years. That's really tough. And in the case of Indonesia, it's very, very challenging. But it depends on how the government act on that.
Okay, thank you very much, Professor. So it's all about depend on the government policy, yeah, about the climate change. Okay, so thank you very much. Maybe we can wrap up this session. Okay, thank you very much for all attendance. And maybe before we close this event, I would like to invite the Director of Internationalization of Hasanuddin University, Jamaluddin Fitrah Alam PhD. Please come to the stage for present or deliver token of appreciation for Professor Masayuki Kondo.
Oke, konnichiwa minasan. Ya, selamat. Check. Okay. Kondo Sensei, thank you very much for your interesting presentation. We all enjoy it a lot. A little bit difficult, but we try to understand. Anyway, I hope all the students also can get good grasp about Kondo Sensei presentation today. And Kondo Sensei, for your information, so the participants here, there is a wide variety of the degree. We have undergraduate degree, and also we have graduate degree students. Also, we have new students. So sometimes it's also difficult maybe for them to understand. But I think in general they are just shy when when you ask question. Jadi untuk adik-adik sekalian, mungkin tadi cukup dipahami ya, cuma mungkin malu-malu untuk mencoba bahasa Inggris. Jadi adik-adik sekalian mungkin yang masih S1, masih maba, masih banyak waktu untuk belajar bahasa Inggrisnya supaya bisa lebih lancar nantinya ya. Sebagai informasi, kita ini sekarang ada program summer course. Jadi kalau lihat kakak-kakak yang di depan ini, can you stand up? Stand up and say hi to our student. Yeah. So these guys from Hiroshima University. You also, can you stand up as well? Yeah. Kalau yang ini sebelah kanan anak S1. Dan mereka baru angkatan 2026. Jadi maba ini. Ini maba yang datang. Say hi to them. Kalau yang ini, ya. Kalau yang sebelah kiri ini mahasiswa S2, ya, you can sit down now. Kalau yang ini anak S1, ini anak S2, dan kita ada program setiap tahunnya untuk summer course seperti ini. Jadi nanti tentu kita mau peserta yang hadir di sini menjadi peserta juga. Ya, tentu harus bisa berbahasa Inggris ya. Saya mau minta tolong kakak tingkatnya Preti dari FIKP kan? Ya, Preti boleh berdiri. Nah, ini ada satu peserta lokal dari FIKP yang kemarin lolos seleksi. Ya. Dan Preti yang ikut ke summer course-nya sekarang. Jadi nanti tentu saya mau lebih banyak dari FIKP juga yang bisa ikut untuk kegiatan-kegiatan serupa ya. Saya kira seperti itu. Terima kasih banyak untuk waktunya. Once again, Kondo Sensei, thank you for your kind presentation today. And next year, we also hope that you can come to our faculty again. Okay, thank you very much. I think we can close this session. Thank you, Bu Alia.
Okay, thank you very much, Jamaluddin Fitra Alam, PhD, for like closing statement. So, ladies and gentlemen, thank you very much for attending this guest lecture, and we also thank to our distinguished speaker today, Prof. Kondo Sensei, who share his knowledge related to gas emission and absorption in mangrove ecosystem. We hope that the collaboration, of course, between Hasanuddin and University and Hiroshima University are getting stronger. And we hope that we'll be in touch again in the near future, especially for Kondo Sensei and maybe other college from Hiroshima University. Especially, we hope that you come again in the maybe next year. Or maybe come with other Hiroshima College. Of course, maybe the last one, thank you very much. Maybe we can wrap up this event. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh. Oh iya, so adik-adik sekalian, silahkan isi attendance listnya ya. Ini untuk kalian mendapatkan sertificate. So for all participants,